Hello and welcome. The date is January 14th, 2026. We are now less than 24 hours away from a moment that will likely be studied for decades, perhaps centuries. The object known as 3I Atlas is currently hurtling toward its closest approach with Earth, an event scheduled for 06:02 Coordinated Universal Time tomorrow morning. If you have been following the mainstream coverage, you've likely heard it described as a fascinating comet or a rare interstellar visitor. But if you look at the raw astrometric data, the numbers that define its path through space, a very different, far more unsettling picture emerges. This is not just a rock tumbling through the void. This is an object that has executed a navigational feat so precise that the odds of it happening by chance are vanishingly small. Tonight we are going to strip away the headlines and look directly at the orbital mechanics of this encounter. We are going to look at why 3I Atlas shouldn't be here, and yet, here it is. Before we dive into the gravitational mathematics that make this object so anomalous, if you want to stay ahead of the breaking analysis on this flyby, as new data comes in over the next 48 hours, make sure you hit that subscribe button and turn on notifications. We will be tracking this live. Now, let's look closer at the data regarding its arrival. When a massive object enters our solar system from interstellar space, it faces a gauntlet. It falls into the deep gravitational wells of the Sun and the giant planets, particularly Jupiter. Normally, this is a chaotic process. A random object, a rogue asteroid, or a cometary fragment will typically do one of two things. It will either crash into the star, consumed by the very gravity that drew it in, or it will be ejected chaotically, flung out on a random vector that pays no heed to the delicate plane of our planetary system. This is the standard model of interstellar interaction. It is messy, violent, and random. 3I Atlas did neither of those things. Instead, this visitor executed what can only be described as a precise gravitational slingshot. It didn't just fall, it threaded the needle. It dove deep into the inner solar system, passing inside the orbit of Mars, using the Sun's gravity to gain immense speed. But here is the crucial detail that many initial reports glossed over: its interaction with Jupiter. The object maneuvered along the very boundary of Jupiter's Hill sphere. For those unfamiliar with orbital dynamics, the Hill sphere is the region around a planet where its gravity dominates over the Sun. To skirt the edge of this sphere is to walk a gravitational tightrope. Pass too close, and you're captured or crashed. Pass too far, and you fail to gain the necessary assist to align your path. 3I Atlas passed on a knife's edge. This near miss was not a clumsy brush with a gas giant. It was a maneuver that avoided capture while keeping the comet on a narrowly defined trajectory. It effectively used Jupiter as a fulcrum to pivot its path. The result? It entered the inner solar system on a path closely aligned with the ecliptic plane, the flat disk where Earth and the other planets orbit. The probability of a random interstellar object entering the solar system on a path so closely aligned with the ecliptic is calculated at only 0.2%. That is 2/10 of 1%. Let that sink in. If you were throwing a dart at a dartboard from a mile away, and you not only hit the bullseye but hit the exact center of the pin holding the bullseye in place, you might begin to understand the precision we are seeing here. Unlike a random asteroid which would approach from any angle, this object slid in sideways, perfectly matching the traffic flow of our planets. So what does this actually mean? It means we have to ask a difficult question. Is this precision the result of a one-in-a-million cosmic lottery win, or is it evidence of something else? When we see a spacecraft from Earth perform a gravity assist, like the Voyager probes or Cassini, we know it requires thousands of hours of calculation and precise thruster burns to hit that keyhole in space. 3I Atlas hit a similar keyhole. It utilized the gravitational landscape of our solar system with an efficiency that mimics intelligent navigation. This brings us to the concept of the gravitational needle. The object's path suggests it wasn't just falling, it was aiming. A rock does not know where Jupiter is. A rock does not know the mass of the Sun. A rock simply obeys gravity. 3I Atlas obeyed gravity, but it did so in a way that maximized its stability and alignment with Earth. We must also consider the speed. It gained velocity from the Sun, but the interaction with Jupiter was the braking mechanism that refined its vector. If it had been slightly faster or slower, or if its angle of entry had been off by a fraction of a degree, it would currently be millions of miles away, likely heading out of the system at a steep angle. Instead, it is here, passing us at a distance that allows for high-resolution observation. As we established in our analysis of the trajectory, 3I Atlas arrived in our inner solar system with a navigational precision that defies the 0.2% odds of a random encounter. But as we zoom in on the object itself, the behavior of 3I Atlas dismantles the lucky rock theory piece by piece. We are now facing what researchers are calling the 15th Anomaly, and it is perhaps the most baffling of them all. Let's look closer at the data regarding the object's rotation. Comets and asteroids rotate. This is basic mechanics. When a natural comet rotates, its surface is exposed to the Sun in a cycle. As the sunlit side heats up, ices sublime, creating jets. 3I Atlas is not behaving like a sprinkler, it is behaving like a spotlight. Observations reveal that while the comet itself is rotating, its active jet remains pointed toward the Sun with an accuracy of 8 degrees. Imagine a spinning top with a dot on it. As it spins, the dot should face you and then turn away, but with 3I Atlas, it is as if the jet is sliding across the surface in real time to compensate for the rotation, staying locked on the Sun. Alternatively, the internal mechanism is selectively activating only specific vents facing the star, switching them on and off with computerized precision. This is the 15th anomaly. For a natural object, this is physically counterintuitive. There should be a thermal lag. 3I Atlas shows no such lag. It maintains a continuous high-pressure stream directed at the Sun regardless of its rotational phase. Such behavior implies sophisticated insulation or internal control. It suggests that the interior of the object is not a solid block of ice, but a structure capable of managing heat flow. But the anomaly gets deeper. After perihelion, as the side facing the Sun turned away, a second jet on the opposite side activated. Just like the first, this new jet locked onto the Sun with 8-degree precision. The probability of this happening naturally twice in a row is roughly 1 in 40,000. I want to pause here and ask you, if you saw a drone spinning in the air but its camera stayed perfectly locked on you the entire time, would you assume the wind was blowing it that way, or would you assume it was tracking you? This sunward lock is a smoking gun for internal complexity. The rotation axis was aligned with the Sun during July and August 2025. This means the base of the new jet was sitting in total darkness for months before it activated, yet it fired perfectly upon exposure. Nature rarely insulates this well. Nature tends toward equilibrium. 3I Atlas is fighting equilibrium. If the movement is strange, the stuff coming out of these jets is even stranger. We usually expect comets to be mostly water and dust. But when the ALMA telescope turned its dish toward 3I Atlas, it didn't see a melting iceberg, it saw a chemical factory. Specifically, the analysis revealed a methanol to hydrogen cyanide ratio of 124 to 1. Typical comets have ratios orders of magnitude lower. Finding this much methanol is like finding car exhaust emitting pure high-octane fuel vapor. But the most startling part is that the concentration of methanol actually increases as you move away from the nucleus inside the tail. This means the tail is not a passive cloud, but a dynamic chemical environment where reactions are still occurring. It looks like the plume of a chemical engine where byproducts are forming after ejection. This chemical anomaly provides the context for the physical force we are observing, an anti-tail extending 500,000 kilometers toward the Sun. To create a structure this straight against the solar wind, you need power. The particles in this anti-tail are moving at speeds exceeding 130 mph. Ordinary ice sublimation produces speeds of perhaps a few meters per second. 130 mph is a thrust. This velocity resembles a retro-thrust jet. If you were piloting a spacecraft and wanted to stabilize your orientation against solar pressure, you would fire a thruster exactly like this. The high velocity implies a nozzle and pressure. This brings us to the 14th anomaly, the shape of the jet. In fluid dynamics, the shape of a plume tells you about the nozzle. A tight, needle-like plume suggests a long, engineered barrel. The probability of these jets forming this shape at random is 25 chances in a million. To maintain a beam that tight over 500,000 kilometers is highly unlikely naturally. Gas wants to expand in a vacuum. The antitail is about 10 times longer than it is wide. When viewed at the calculated 10-degree angle, the true length-to-width ratio is approximately 11.6. This is a tube, a cylinder of gas. Sunlight would only illuminate the bottom of a natural gun barrel hole briefly as the comet rotated, yet the stream is continuous. This suggests the mechanism is not dependent on direct sunlight hitting surface ice. If these are technological, they could serve as directed shields, firing gas toward the star to create a plasma bow shock, an umbrella to deflect radiation and keep the interior cool. When you stack these probabilities, the 0.2% trajectory, the 1 in 40,000 rotation lock, and the 25 in a million jet collimation, you reach a net probability of approximately 1 in 4 billion. If you bought a lottery ticket every day for 10 million years, you might hit these odds once, and this doesn't even count the high nickel content detected, which resembles industrial alloys more than silicate dust. What is 3I Atlas? Is it a derelict probe, a functioning surveyor? The mainstream silence is deafening, but the data speaks for itself. For those of you who want to see this history-making object, the window is closing. The comet reaches closest approach on January 19th at 06:02 UTC. In London, that's 06:02 GMT. In New York, 01:02 EST on the 18th. In Los Angeles, 22:02 PST on the 18th. It is located in the constellation Leo, just below the star Regulus. You'll need a telescope of at least 8 inches to see its +112 magnitude faint glow. 3I Atlas has challenged our models and defied our statistics. It might just be our first glimpse of technology that is not our own. If you found this deep dive valuable, hit the like button and subscribe for updates as we analyze the post-flyby data. The story of 3I Atlas is far from over.